So hello all. In this lecture series of computer organization and architecture, today we will be discussing the types of CPU organizations. What are some basic types of CPU organizations that we see in this subject? So first type is single accumulator organization. Single accumulator organization. And second type is general register organization. General register organization. And third type is stack organization. Stack organization. So these are some basic types of CPU organizations, and they are capable of executing some different types of instruction. Like single accumulator organization is capable of executing only zero address and single address instruction. Only zero address instructions and single address instruction, one address instruction. Okay, later on we'll be going to see what are zero address and single address instruction. And a general register organization is capable of executing two address or three address instructions. And the stack organization, on coming up to stack organization, it executes only zero address instructions. Okay, so we will be going to see the three basic types of CPU organizations. So the first type is single accumulator organization. In this single accumulator organization, we design a CPU in which we do not include some general purpose registers like HL pair registers and all. Instead of that, we include some basic registers which are necessarily required to execute our instructions. Okay, so let me draw a diagram which will clear you the picture of single accumulator organization, how it works and all. So here it is a bus, and bus is connected, and a memory is connected with the bus. Memory is connected with the bus. So as we all know that a data in a CPU, some data in a CPU or some instruction or any kind of data is traveled with the help of a bus. Okay, so in the upcoming lectures we will be seeing the working of a bus and how a bus works, bus select and all. So in this is a bus and a memory is connected with it, and ALU is connected, and ALU is connected with it, and to an ALU an accumulator register. Accumulator register is nothing but is a register which holds the computation results of ALU. It holds the computation results of ALU, and it also a medium to provide inputs to the ALU. Okay, through accumulator register we provide some inputs to the register. We can also provide inputs to the register with the help of input register and data register and all, but here we will be discussing single accumulator organization, so no need to include the data register and all. And we will be having in a single register organization, single accumulator organization, one register called program counter, which is responsible for storing the address of next instruction, and instruction register. Okay, so what's the use of instruction register? Instruction register holds the instruction which is just fetched from the memory. Okay, how you are going to execute an instruction? You have to fetch an instruction from the memory, you have to decode and all. So here what are the phases of an instruction? Fetch. Instruction is firstly fetched from a memory, then second it is decoded, and instruction is decoded, and according to the result of that decoding an instruction is executed, and it is written back into the memory, and the fourth stage it is written back into the memory, or it is displayed to the some output device that is connected. Okay, right back to the memory, or it will be given to the output register, which will which will be used for giving outputs and all. So here we do not have some general purpose registers which will hold our data. Okay, so in this organization data will be traveling from a memory to the instruction register, and instruction will be fetched from a memory, it will reside into the instruction register, and from instruction register it will be decoded, and according to the result of that decoding an execution is performed. Okay, so here we will be seeing the instructions like INCA, which is nothing but to increment an accumulator. The contents which are present on an accumulator will be incremented by 1 with the help of this instruction INCA. And what if we want to load an accumulator? We will be giving an instruction LDA. LDA means to load an accumulator. Okay, or load instruction or load accumulator. So single accumulator organization is capable of executing only single address and zero address instruction. Here INCA is a zero address instruction. Which means to increment an accumulator, and in this instruction we will not be giving any addresses. Okay, will not be giving any addresses. So it is a zero address instruction, and load y or load accumulator. LDA means load accumulator, and load y means to load an accumulator with the data present at yth location in a memory. Okay, to load an accumulator with the data present in a yth location in a memory. So it is a single address instruction, one address instruction. It is single address instruction. Load y is a single address instruction. So when I am talking about instructions, you will be seeing the instructions like add R1, R2, R3. So what is this? This is an instruction which is having 3 addresses. So it's a 3 address instruction. So it's a 3 address instruction, and our single accumulator organization is not capable of executing these types of instructions. Why it's not capable of executing these types of instruction? Because we do not have these general purpose registers R1 and R2 and R3. We do not have these types of register. Instead, if we want to perform this operation, what is this instruction? This instruction means the computation results of the addition results of R2 and R3 will be stored in a register R1. Okay, add R1, R2, R3 means the addition, the computation result of R2 and R3 are loaded will be loaded into a register R1. So if we want to perform this type of instruction, if we want to execute this type of instruction with the help of a single accumulator organization, where the registers R1, R2, R3, these general purpose registers are not present. So how can we perform that? At first we will be going to load our accumulator. Okay, load our accumulator LDA. Y. Okay, so the data which is present at the operand, or data which is present at yth location in a memory, will be loaded into an accumulator. After that we will be giving add x. Okay, so firstly, how this is going to be performed? This is an accumulator register. Once we have given this instruction LDAY, so what will it do? It will load the instruction, it will load the register with the contents present at yth location in a memory. So suppose at yth location in a memory is 5, so 5 will be loaded here in the accumulator, and after that we have given add x. Okay, so after giving add x, so there is some x location in the memory where something is stored, some data is stored, so it will be added to the accumulator, and the result also will be saved back into the accumulator itself. Okay, so this three address instruction, we are going to perform this 3 address instruction in a single accumulator organization in 2 to 3 steps. Okay, so what you have noticed here, that if we reduce the number of registers in our CPU, so the steps which are required to execute some instruction, some big instruction like 3 address instruction, so the steps will increase. If we reduce the number of registers in a CPU, then the steps to execute a particular instruction will increase. Okay, so here we have seen a single accumulator organization. Now come on to a general register organization. So in a general register organization, we have this basic registers, and add on to that we have some general purpose registers, also. So like R1, R2, R3, R4. So these registers will hold our data which is fetched from the memory, or which is provided as a input from a input device. So it will be residing in these registers, and we will be loading these registers one by one to the accumulator, and from accumulator these the data which are present in the accumulator will be given to the ALU, and ALU will perform the required operation, and it will give the data back to the accumulator, and from accumulator we will be giving the data accordingly which is specified in the instruction. Here in this add R1, R2, R3, so this type of instruction can be executed by a general register organization, because we have some general purpose registers in this R1, R2, R3 and R4. Okay, so this will be executing, this is capable of executing our 3 address instruction. So how at the back end, how this instruction execution will take place. So firstly, the contents of register R3, the contents of register R3 will be loaded to the accumulator, will be loaded to the accumulator, will be loaded to the accumulator. The contents of R3 will be loaded to the accumulator, then it will be given to the ALU, and then the accumulator is overwritten with the contents of register R2, and it will also be given to the ALU, and ALU will perform addition operation, and it will give the result of computation to the back to the accumulator. Okay, so in the accumulator, what you will get, you will be getting the result of addition of two of the contents of two registers R3 and R2. Okay, and from accumulator it will be loaded to the register R1. It will be loaded to the register R1. So this will be taking place like this. And let's come on to the third type, our stack organization, our stack type of CPU organization. Stack organization. So in stack organization, we will be having registers like we have in general register organization. We will be having registers, a bunch of registers which are arranged in a stack fashion or in a stack manner. These are arranged in a stack manner, R1, R2, R3 and R4. These registers are arranged in a stack manner, and once we give the instruction push, X, so X will be pushed on the top of the stack. So consider these registers not as a registers, but as a block of a stack memory. Okay, so once we give this instruction push X, so X will be pushed to the register at the top of the stack, and then we will be giving the push Y. So Y will be pushed on the top of the stack, and once we give the add instruction, so the contents at R2 and R3 will be added here. So you will be confused that we here stack organization is capable of only executing 0 address instruction, but here I am giving this push X and Y. So these are not the instructions which are related to that CPU. Okay, so these are the instructions which are related to the stack memory. Okay, and add is the instruction which is related to that. So giving an add instruction, we have not given any address here. Okay, so in the stack instruction, the execution of instruction will be take place like this. Okay, thank you.